So hello everyone, in this video we'll be solving another LeetCode problem, and the problem name is longest balanced subarray part 1. So you are given an integer array nums. A subarray is called balanced if the number of distinct even numbers in the subarray is equal to the number of distinct odd numbers, and we need to return the length of longest balanced subarray. So the problem statement is pretty much straightforward. You have been given an array nums. You need to find the length of longest subarray such that the number of distinct even numbers in that subarray, distinct even numbers, should be equal to number of distinct odd numbers. So this is what the problem is saying. So let us see with the help of example how we can get a better understanding of the problem statement as well. So you see, this is the first example. The nums array is given as 2, 5, 4, 3. So we can take this entire array as the sub array, because if you see, the number of distinct even is what? 2 is 1 even and 4 is 1 even. So number of distinct even number is 2. How many distinct odd numbers are there? 5 and 3, 2. So in this entire subarray or this entire array has the number of distinct even equal to 2 and number of distinct odd equal to 2. So both are equal. So the length is 4. So that's why we are returning 4, because if we are taking the entire nums array as the subarray, you can't get a length more than that. So that's why the length is 4 and the answer is also 4. So let us see one more example. Here you have been given the nums array 3, 2, 2, 5, 4. So in this, if you see, again this entire array is the subarray which we are taking as the longest subarray, because if you see, the number of distinct odd numbers and number of distinct even numbers are how many? 3 is one odd number, 5 is one odd number. So total number of distinct odd number is 2. 2 is one even number, 4 is one even number. 2 is again an even number, but we will not count 3, we will count 2 only, because 2 has already come previously, so it is repeating. We need to take care about the only distinct even numbers. So 2 is one distinct even number and 4 is one distinct even number. So total number of distinct even number is 2. Both are equal, so we need to maximize the length. We can't get length more than the array size, so that's why the entire array is the subarray that we are taking. So that's why the answer is 5. If you look at the output is 5. Let us see with the help of another example in that in which we are not taking the entire nums array as the subarray. So in this example, this is the nums array that is being given to us 1, 2, 3, 2. In this, we will not be taking entire nums array as the subarray, because if we take entire nums array as the longest subarray, the count of distinct even and count of distinct odd will be what? Here it has 1 and 2 distinct odd numbers, so we will write 2 distinct odd, but you see only one distinct even number is there, so they are not equal. So entire subarray cannot be the longest subarray which holds the property, so we need to take some other subarray. So what subarray we will choose? We will choose this subarray of length 3. So in this, if you see, number of distinct even and number of distinct odd is what? Distinct even is 1 and distinct odd is 1. So they both are equal. That's why this is the right output, length 3. So that's why you see the output is 3, because 3 is the longest subarray which has the number of distinct even and distinct odd as equal. So this is what the question is saying, and this is pretty much easy problem to solve. The constraints of this problem are very low. I think around 1500 only on the nums length. So we can apply the brute force approach as well. So what can be the brute force approach? Let us see. So let's say you have been given this nums array 1, 2, 3, 2. So in the brute force approach, we can try each and every subarray. We will try this subarray, this subarray, this subarray, this subarray. Then we will start our next subarray from here. We will try this subarray, we will try this subarray. Again we will start our new iteration from here. We will try this particular subarray, then this subarray, then in the end we will try this subarray. So for each and every I, we will keep moving our j pointer ahead, and I will also be moving forward until it reaches n. So I will go from 0 to n, and for each I value, j will also go from I up till n. So we will get each and every subarray. So by this we will get each and every subarray, and we can keep two unordered set. One will be counting the distinct even number and one will be counting the distinct odd numbers. So when we have a particular subarray, we are keep on adding these elements. If it is even, we are putting it into the unordered set even. If the number is odd, we will push it into, or we will insert into unordered set which is odd. After the subarray we have chosen, we will check if the even size is equal to odd size or not. If it is true, that means the condition holds true, so we will try to maximize our answer. So we will also be keeping an answer which will tell the maximum or the longest subarray length that we have till now. So if this current subarray length, what is the subarray length in terms of I and j? The subarray length is nothing but j minus I plus 1. So if this current length is greater than this current maximum answer, so we will update our answer with this current length. So this is what we'll be doing. We'll be using the simple brute force approach only. So let us see the code now. So in the code you can see I have declared one integer n, which is nothing but size of the nums array, answer 0, which will tell the longest length of the subarray, which holds the property of distinct even and distinct odd. Now what we are doing, we are checking each and every subarray. So subarrays, how will we check all the subarrays? We are running I from 0 up till n, and we are running j from I up till n. So it will check each and every subarray. Now for each and every subarray we need to count distinct odd and distinct even. So we are declaring two unordered set, distinct one will keep track of distinct odd, that is named as odd, and one will keep track of distinct even numbers, which is named as even. Now if the number is an odd number, we will insert it into the odd set. Otherwise, if the number is even, we will insert it into even set. After the insertion of the element, we will check whether this odd size is equal to even size or not. What this will tell? This will tell if total number of distinct odd numbers is equal to total number of distinct even number or not. This will tell this. Why? Because set will always keep track of the distinct element. So if both are same, that means our condition is matched. Now we try to maximize the length of the subarray. So what is the current length? Current length is nothing but j minus I plus 1. So if this current length is greater than this current maximum answer, we will update our answer with this current length. So we will keep on doing and keep on trying for each and every subarray. In the end, whatever maximum answer we get, we will be returning in the end. So I hope you learned from this solution. Thank you for watching.